So, first of all, good morning, all of you. And today, that is the topic, which is the MPLS, right? So, how we are going to like how we need, why we need MPLS, what is the use of it, right? So, these things we are going to talk about the MPLS, okay? And before coming on the MPLS, what we are going to do, we are going to talk about the traditional routing, right? So what is the traditional routing and what are the things like how it works? So we'll also talk about it, right? So traditional routing. So inside the normal routing, if I'm talk about, so we have suppose that we have the layer 3 device, right? So inside the traditional routing, we have the three types of traditional routing, right? Process switching, the second one that is, then we have fast switching, and then we have the last one that is self switching. Okay, so let me just first of all discuss like what is this basically, right? So inside the process switching, what we have, like if we have any layer 3 device over here, so what we do, like it manages the two things, right? That is the data plane traffic and control plane. So with following this, suppose that this is our layer 3 device. Okay. So inside the data plane traffic, we have the all the port information which is we have on the data plane, right? Means whatever the users are attached. So where it attached on the data plane. Okay. So the data plane have the all the kind of users information or the port information, you can say that, right? So in the inside this process switching, what is happening over there? So we'll talk about first one, right? That is process switching. So suppose that here we have the two PCs, right? Now here we have also one more PCs, right? Suppose that have the IP address 10.1.1.1, and here we have the IP address that is 20.1.1.1. Okay. So what this will do? Suppose that this one wants to make the connection with this destination PC, right? So what this will do, this will generate a packet, right? And inside the source IP that will share at 10.1, inside the destination IP it will share that is 20.1. So what will happen? This will just share that packet towards the data plane. And the data plane, what this data plane will do, the data plane basically will check it, and then it will just send it to your control plane. And inside the control plane, the routing table is going to maintain it inside the control plane, right? Means CPU and routing table and these kind of information is going to maintain it by the control plane. Okay, and the memory like flash memory and all the things will be managed by this data plane, right? So what this will do, this will just generate, first of all, this will send that packet to your control plane, and then control plane will look like where it is coming from. Means this will maintain the one of the routing table, which is a need to send any kind of data from source to destination in future as well. So this will maintain the routing table, and then it will revert back to it the data plane traffic. Because of this will identify that like whatever the packet I'm getting it, the source would be 10.1, right? And the destination would be 20. So what this will do, this will just after maintaining the routing table, this will check like, okay, means who is going to responsible to who is responsible to send these kind of managing regarding the port and all the things. So this will look that this is not my work, right? This is not my work. This is the work of the data plane. So again, this will transfer that packet to the data plane, and data plane and traffic will move out to your destination, right? So this was happening in your process switching. Okay, now after that, then we have the process switching, right? So inside the fast switching, we have second one, that is fast switching. Okay, so inside the fast switching, what we do, like the same process, we are also going to just take it, right? Some differences we have inside the fast switching, so that differences we are going to talk about, right? This is our data plane, and this is control plane. Okay, so what this will do, this will start sharing that that packet which is it needs to share it, right? But after that, here we have the rib table, that is we call routing information base, right? And the routing information base, we can call it like we can say that the routing information base is the second name, that is routing table, right? So inside the routing table, this will just forward that packet to the routing table, right? Means this will forward it, and then just then again it will just make a shortcut entry, right? Means the fact first packet will send it to your routing table to maintain the connection, to maintain the neighborship, right? And then this will forward that packet to your data plane, right? And data plane will move out to the destination, towards the destination. But this inside the fast switching, only once at a time, this the packet is going to send it on the control plane, right? But the rib is working on it. The rib is working on the controller plane, and then it will just transfer that packet towards the data plane once again, right? Means inside the process switching, the all the times if you wanted to share any kind of files folder to from source to destination, so all the time they will just they will just send it to the control plane, and then they will just send it to the again then the control plane send the data again to the data plane, right? So there was reducing of memory, right? And the CPU utilization is also going to be very high. Okay, now after that, what will happen? Then we have to reduce the time, reduce the process of the CPUs and the all the things, right? Then we have safe switching, right? So inside it, we have SEF means Cisco Express Forwarding. Cisco Express Forwarding. Okay, so that is the name of it. So what will happen over here? So the same process is also going to find out, like the data plane we have, right, and the control plane. Now we have the rib table over here, that is gonna be maintain the all the routing table information in that. But we have FIP in that data plane, right? This will also send they send the query to the FIP, that is the called forwarding information base. Forwarding information base, right? Means whatever the forwarding packet that it wants to look at, so this will make the table, right? So this will just whatever the packet that is this read table is going to maintain it, automatically it will forward to the forwarding information base, right? And sorry for that, actually this is not the part of the data plane, this is also the part of the control plane, right? So this is also going to maintain by the control plane. Okay, So whatever the packet is coming inside the control plane, so what this will do, this will just first of all, after maintaining the routing information, this will forward that packet to the forwarding information base, right? Now after that we have the ceph over there. Okay, inside the ceph we have multiple things like fib table, L fib table, right? Local forwarding information base. So first time this will forward to the FIB, means this is not going to maintain the routing information again and again, right? This will directly, if the packet is coming, so directly it will forward to the forwarding information base first time, right? Only once at a time it will forward to the forwarding information base, and then it will again forward to the ceph, right? So inside this ceph switching, what is happening over here, we have local forwarding information in that, right? Means the all the kind of packet that is we have, so that is always the local forwarding information base. Okay. So for forwarding this kind of information, first time this will forward to the control plane, and again then directly they will forward directly to the ceph, and then ceph will totally responsible to send the data towards the sender and the receiver, right? So this is the traditional routing which is we have. Okay. Now let's talk about the MPLS. Okay, like what is that? So there are two questions that is we have in our mind, that is what is MPLS and why we need MPLS. If I have already BGP and now these kind of protocols, so why we need it? So when you look the MPLS towards the look the MPLS, so the MPLS basically we use for the service providers, right? So we have multiple kind of service provider. Okay, so over here we have multiple things, right? Means we can just perform the tunneling, that is GRE tunneling, we can also perform it, and then we can just make the BGP neighborship as well, right? Between the multiple customers, who is going to responsible, that MPLS is going to responsible for it. Okay, now let me just explain one packet over here, right? Means regarding the MPLS packet. Okay, like what is the MPLS packet that we are going to get it, and inside the packet what are the things is going to send it, and what will be the size of packet, what are the content that we are going to send it inside the packets. Okay, so let me just, so we have this MPLS header. So inside the MPLS header, we have multiple kind of bits over here. So the size we will also talk about it, right? Means the 20 bit would be we use for the labels, right? Means 20 bit we use for the labels. Okay, and the 3 bit would be your experimental bit. 3 bit.
Aman, your voice is getting very low.
Yes, is not audible.
Just now it is fine.
Yes, sir, now it is.
Now the 1 bit that is we have bottom of stack bit, right? S bit we can say that bottom of S bit, and the remaining 8 bits will be your TTL, right? TTL. So now over here, if I'm talk about the labels and all, so the inside the labels, what are the things is going to maintain it in that regarding the information of the of our the tags, right? Which is coming, which is managing by the data plane and the control plane, right? Means the LFIB and fib table. Okay, so these kind of labels is going to maintain it in that, and The experimental bit, if you remember, like if you have learned the kind of IP header. So inside the experimental bit, we have the three more bit over there. Like inside that, we can just add some another tags over there, right? Regarding the any packet. So this is used for the another tags. Okay, and bottom of stack bit is also we can just call it. It's also the kind of part of the IP header. Okay. This is, or we can call it this 3-bit, we can call it IP precedence value. Okay, this 3-bit is we use for the IP precedence value. Means we use to prioritize the data from source to destination, or we use to prioritize the data from to categorize the data into the experimental bit and sorry, in the MPLS header, right? In this kind of fields. Okay. Now, what is the use of S bit over here? So the bottom of stack bit, that is we called it bottom of stack bit. Okay. So what is see basically the TTL, you also know that, right? Okay, so I don't think so explain the TTL value over here, right? So these are the things, these are the kind of MPLS header that is it's going to maintain it, right? So inside that, if I'm talk about the whole packet of the MPLS, so how the packet is going to send it? This is our packet, okay? And inside the packet we have, this will add the MPLS header, and then it will also add the HDLC header, right? HDLC header means this will be inside the HDLC header. We have all the information regarding IP address, MAC addresses, and all the things, right? So this is the use of packets, and this is the packets of the total packets of the MPLS header, right? And this is how we can use it. Okay. Now, if I'm talk about bottom of stack bit, so there can be the multiple labels with a one packet, right? Means if one packet is coming inside the control plane, so it doesn't matter that how many kind of labels that it is taking it. That can be the multiple labels, right? That can be the multiple labels, right? So to categorize that label, to categorize that packet, we use bottom of the stack bit, right? Or multiple MPLS header can be also attached inside this bottom of stack bit, right? Multiple header, that is MPLS header. Okay. So the multiple MPLS header can be also attached with the kind of this packet, right? If Now, if the bottom of a stack bit called it, or you can identify as a 1, so that means this is the last value before the IP header. Means you can also call it last header before IP header. Okay. So this is the all the things which is regarding the MPLS header, and always just keep remember if any packet is coming and if you are using MPLS, so before the HDLC header or the IP header, always the MPLS header will comes first, right? So these things would be followed by every steps, right? Now, we have the multiple kind of headers as well inside the MPLS, right? Now we have suppose that this will categorize, let me just categorize this into the two part of this MPLS header. Just suppose that we have the two multiples header in that, right? Because of the headers can be multiples, right? So how you can categorize it with using inner and outer header, right? Inner and outer header. So with using the inner and outer header, you can identify how you can identify with using of bottom of stack bit, right? If we have, if it's the bottom of stack bit, if using this stack bit is using before the IP header, then the this stack bit will comes on, and then the after inside the MPLS this will comes off, right? So this will how you can identify that which one is our outer header and which one is our inner header, right? So this is how you can identify, like regarding the bottom of stack bit, this is how you can identify that, and this then you can just categorize it into the multiple kind of headers as well, right? Now let's move on the basics part of the MPLS VPN. Okay, means why we need it, and like what is MPLS VPN that is we have. So we'll also talk about it. Okay, so let me just label. Let's talk about label devices and all the things, right? Because of the labels, which is the labels is most important, right? And this is the labels is going to manage by this MPLS header. Okay, so as we discussed over here, the MPLS header have the 4 bytes of the value, right? The label value, experimental bit, S bit, and TTL value, right? So what is the S bit? That is we use it. So this is the bottom of a stack bit, right? With MPLS, it's possible to add more than one label. You will see why in some of the MPLS VPN lessons. When this bit is set to 1, it's the last MPLS header before the IPLS header, as I told you, right? Now let's talk about the MPLS header, like the MPLS labels that is it's going to send it, right? So the MPLS label that is going to generate it, that is between 1 to 15, sorry, 0 to 15, right? Means to the power 15, okay? Means sorry, 1 to the power 15. So this will just identify you that the MPLS label, right? Means how many kind of the label power that it have, and the MPLS external bit, that is experimental bit, right? That is this one. So this will also show you inside the MPLS, right? Means the if the experimental bit is turned off, so there is no need to work on it, right? So if the bottom of a stack bit is on, right? If the bottom of a stack bit is on, that means this is the last bit before IP header, right? This is the last header before IP header. So here is our MPLS TTL, right? And then just after that, as you can see over here, that is our internet protocol version, that is the IP header, right? So all the kind of information that the IP header, which is going to manage it. So these all the things is going to manage it before that. Okay, means before the IP header, as we discuss over here, that before the IP header, it always add the MPLS header, right? Either we can use the HDLC header over here, right? But over here, as you can see, we are using the IP header before the and the MPLS header is going to attach it before the IP header, right? So these are the things which is you can identify, and then you can um, just categorize it into the multiple kind of things, right? Now we have one more thing over here. I just forgot to explain it. Basically, we use this bottom of this experimental bit for the one purposes as well. That is class of service, right? That is class of service, right? So what is the class of service that is? Over here, MPLS header in between the Ethernet and IP header, you can also see the different fields. The header uses label above 16. You don't use quality of service, and since there is no one MPLS header at the bottom of label stack which has been set, right? So here is the two protocols inside the MPLS, that is LDP. Basically, by default, which is we use the LDP protocol, right? That is we call label distribution protocol. Okay. Now we have the some customer edge and provider edge also over here. I think that one is also mentioned in your uh, in your basically in your this training content. So the customer edge and the provide edge we are also going to talk about, right? Means how you can identify that this is our customer edge and this is our provider edge. So the customer edge would be uh, means after the ISP there will be the customer edge, right? Means let me take a scenario, then you can understand. So inside this scenario, this is our customer edge. This is our customer edge and this is our provider edge. Okay, means the service provider, where the service provider is going to exist, that is the our provider edge. Means this is going to provide us the services regarding anything, right? And the customer edge always request for the services to the internet and all the things which is we have. Okay, now let's move to the next part, like what is the customer edge, what is the provider edge, and what are the things that is we have. So the customer edge, this device is the last device in the customer's network. It could be a layer 2 or the layer 3 device, right? So that can be the layer 2 or the layer 3 device, it doesn't matter. Okay, so in this device we cannot use the MPLS because of we MPLS where we can use it, we can only use on the provider edge customer provider edge routers, right? Where the ISP or where the internet is going to exist, right? So between the internet and the provider edge, we basically on the internet and the provider edge, we use the MPLS over there. Now, what is the provider edge? This device is owned by the ISP and sites at the edge of the ISP's network, right? It has an important role in it receive packets or frame from the customers, and it will then add a MPLS label to it and from forward towards the core, right? Another common name of this device is LER, label edge router, right? Means we have the two names, that is we called it like provider edge, we can also call it or we can just call it the label edge router, right? Somebody is called label edge router, so that would be good as well. And the provider edge router would be easy to understand. Okay, so what this will do, this will just they will not able to configure the any kind of MPLS, right? They always work on the basically OSPF and the EIGRP and all the things, right? They will not work on the BGP and your we can work on the BGP, we can configure the BGP, but we cannot configure the MPLS on it, right? Means we can configure the IGP protocol and AGP protocol in that, right? But on the customer edge, we use the MPLS. We can use the MPLS on the provider edge, right? Now, the provider edge is able to configure the MPLS, and then it will what it will do, it will add the packet, right? Add the labels, and then the labels will provide the services to your customers, right? As the discussed in this provider edge. Okay. Now, provider means this device connects to provider edge routers, and the provider router, it has a simple job. It switch packet based on their labels or remove the labels. Another common name of the device, that is LSR, label switch router or transit router. Mostly we say the transit router, right? Mostly we say transit router. So keep remember the name, that is transit router. Okay. So what is that? This is used to provide the labels, or this is used to you remove or add the labels which is coming on the provider edge, right? There are three actions we can perform with the labels, right? So like this transit router perform three kind of label, right? This transit router is able to perform three kind of labels. That is label push, label swap, and label pop. That is we call pop label, right? So the push label, what is the use of it? When we add a label to a packet, we called it a label push, right? Means whenever any packet will add it in that, so that means that is we called it label push, right? And label swap means replacing a label with another value is called a label swap. Means the P router, whatever the work of P router or the transit router, what this will do, this will add some kind of like if the P router will get some packet. So what this will do, this will first of all this will make some modification in that packet, like modification in that labels, and then it will transit it, right? So that feature we called it label swapping, right? That feature we called it label swapping. Okay. Now the what is a pop label? Remove the label is called a label pop, right? Means this can also add the label and this can also remove the label if it required, right? So if that is going to remove the label, so that means it is popping the label, right? Means we cannot say that it is removing the labels. We can say that it's popping the labels, right? So according to the labels, they just categorize. The P routers categorize. Okay. So let's take the example like how this can swipe the packets and all the things, right? So what this will do, this will first of all send a IP packet, right? Because of the customer edge router will just try to basically request for any kind of packet, right? So this will send the packet to get the IP to get the internet connection, and this will move on the provider edge router, right? So this will receive the IP packet push label. So what this will do, this will work on a push label and then it will forward it on the P routers, right? So the P router will receive it and then it will swipe it, right? Means whatever the label that the P router is getting it, this can remove the label, this can swipe the label, and this can do some modification in that label as well. So what is the kind of request that is? So according to the request, they will work on it, right? So the P router will get the packet, get the label, and they will just look like what kind of request it is. So this will just send this will just swipe the label and then this will forward to the another P router. So this will also swipe the label and then it will just pop the label, right? And then it will remove the request label. Means okay, means I got your request. Now I'm going to provide you the service. Okay. Now what this will do, this will provide the packet of the route. Okay, this will just receive the label and then pop it, means it will just remove it towards the provider edge, right? Now the provider edge will receive the IP packet, route from it, and then it will just send the packet to the customer edge, right? So this is the how the things is going to be work in that. Okay, guys, do you have any doubt in that? Any things to ask if you have?
Yes, Aman sir.
Yes, please go ahead. What is?
Sir, in the last image, you have shown that this P router, yeah, this image only. So in this, these labels and all this I received an IP and sent. So this I am not able to. Can you please repeat this?
See,
The function of P router, how
yes.
they transmit the labels.
See, what is the function of P routers? Let me just tell you over here, right? Let me just. So, as you can see over here, this device connects to PE router, means this is directly connected with the provider edge routers and other P routers as well, right? We have the other speed routers as well in the picture, or are we can be, right? Now it has a simple job. What is the job? It switch the packet based on their labels, right? Means whatever the labels that is coming, like they will just first of all work on the labels, like what kind of labels it is, like this is a request label or something like that. So this will switch the packet based on their labels or remove the labels, right? Means remove the label means this is popping the label. After replacing it, they will remove the label. Another common name of this device, that is LSR, right? Means after removing the label, this will just send it to the provider edge router, right? This will send it to the provider edge router. Because of this, the labels which is this P router is getting, which is coming from the provider edge, and what kind of label it is? It is the request label, right? Request for the any kind of services. Okay, so this will just pop the label, and then it will just send it towards the provider, and then provider edge, and then the customer edge will get the IP. Okay, as you can see in this picture, this will receive the label and then it will swipe it, right? Means they just swipe the label, and then it will just again swipe the label, and the last P router will pop the label, right? Last P router will pop the label, okay, to provide the services to your provider edge, and the provider edge will give you the IP. Okay.
Sir, in this, all the three routers are placed simultaneously. Sorry, work on मतलब simultaneous मतलब एक के बाद एक से तीनों राउटर काम करते हैं,
Yes.
या कुछ एक भी हो सकते हैं या दो भी हो सकते
There can be. See, what is the use, like the provider edge, the P router, first of all, what is the use of the P router? What this will do? This will first of all, this can also receive, this will receive it, this will swipe the label, and then this will pop the label, right? So there can be the multiple route, there can be the multiple router or the multiple P router, or there can be a single router as well, right? So doesn't matter. Okay, but they will just work on their functions, like they will just swipe the label, and then they will just pop the label after that. Whatever the, if we have only one single router on the P, if I have the two routers, or if I have the three routers or four routers, but where the pop is going to be happen on the last router. Means if I have the two routers like it, like that, this is our customer edge, this is our customer edge, and this is our provider edge, right? PE, and this is our P routers, right? So what this will do, this will just this customer wants to ping it from here to here, right? So what this will do, this will generate a packet, right? This customer will generate a packet, and then it will reach on the provider edge. This will reach on the provider edge, and then provider edge will send it towards the P routers. So P routers, what this will do, if I have only one router over here, so what this will do, first of all, they will just work on it. Like they will first of all swipe it, and then it will move to the pop. Okay. Then after popping it, this will provide the labels to the provider edge, and then provider edge will give you the give you this label to your destination, right? So this is how it's gonna be work. Either it can be, see, if there be the four or five routers in the P, so what this will do, like they will just swipe it, they will just swipe it, but in the last provider routers, they will pop it. Means only last router towards the provider edge, that provider router only do pop, right? Others will always do swiping, right? If you have only one router in the P, so this will work on the swipe and then pop, right? So this is the use of it. Understood, guys? Guys, understand?
Yes, sir. Though this is something new, MPLS,
Huh.
but yeah, we were trying to understand.
Okay, no problem. If you have any doubt after this, so we'll
We
also.
have to look more basic videos on YouTube as well. I mean, to understand all these things because
See,
it's just the revision,
yes, yes, yes.
right?
For the revision, I will also refer you to some videos as well, right?
Yeah,
Don't worry.
sir. Yeah, if it is possible, if you could put in the basic MPLS video over your channel, so that would be good as well.
Okay, no problem. We'll do that as well. Okay. So,
Yeah.
but these things is the basics. Like these are the basics of the MPLS. If you say that the routing table and all the things is the higher level of the routing, so there is your fault. That is your fault. Means these are the basics of these any kind of protocols. Means at least whatever the rules of the protocols that is we have. So at least we have to learn it, learn about it. Like how it will work. What is the AD value of that protocol, right? What is the internal external AD
Yes.
value of it? So these are the features of it, right? Means if you did not
Yes.
understand the features like how the MPLS works, so how you can understand that what is the P router, what is the provider edge, what is the customer edge router, right? So we have to
Yes.
finally
Yes, sir.
okay.
Yeah, so we are trying to pace this up with, I mean, we are referring this and we're referring the basic topics of MPLS and the other protocols as well, so that we can get the understanding.
Yes, we can.
Because yeah,
Well,
this is what we are trying to
we'll
do.
do one thing. I'll do one thing. I'll take the best scenario over here, right? I'll just try to explain it once more. Okay. But after the break. Okay.
Okay, okay.
Okay. So just take your 20-minute break. We'll get back to you. So we are going to take the protocols, right? And I will explain, like, first of all, how the provider routers, provider edge, customer edge, and the P routers works, right? With using the protocols, so that that you can understand that how the flow is going on in that. Okay. So let me draw the scenario. I'm going to take the same scenario, right? But over here, what I'm going to do, I'm going to just take the multiple protocols over here, right? That is provider 1, provider 2, and I'm going to take 3 provider routers, provider 3, right? And over here we have customer provider edge router, okay? Provider edge 2, provider edge 1, and here we have the customer edge router. Customer edge 1 and then customer edge 2, right? And here we have the switches. Okay, so the protocols which is we are going to use over here, that is between here and here. I'm going to use any IGP protocol such as let's take OSPF, right? And now on the provider edge, we are going to use BGP protocol, right? BGP, and here is our whole MPLS. Okay, so this is our MPLS. Sorry. MPLS. Okay, now the redistribution is going on the provider edge, right? Suppose that. So what I'm going to do, suppose that this user wants to communicate with this user, right? So what this will do, this will generate a packet, right? And inside the packet, we have the IP information, right? MAC information, and we have a type field, Okay, and we have protocol field. So these we have, what about the field or the packet requirement that is this customer edge router have? So this will generate it, right? So it will this packet will receive on the provider edge. So provider edge will look like where I have to send it. So this provider edge will look that okay, I have the directly connected neighbor which is running inside the MPLS, right? So this provider edge on this provider edge the MPLS is also running, right? Because of this provider edge is the part of the both protocol that is BGP and MPLS. Okay, so this will just convert a packet into the labels. Okay, this will convert into the label, and this labeled packet will share it right with using alfib alfib table and fib table. Okay, so this will maintain that tables and then it will forward to the provider, the P routers. Now, what is the use of then P routers? Now, once the label will receive on the P router, once the label will receive on the P routers, then what is the basic function of the P routers? So the basic function is first step that it will do swipe, right? This will swipe the packet into the like this will look that like do I have any other provider routers or not, right? So if you have suppose that four routers or five routers between that, so they will also swipe that, right? They will also swipe it. They will also swipe it till the last router. Till the last router only this router is responsible to pop the label. Why? Because of once the label will receive on the this router after swiping all of the routers. So what this will do, this will check like see every router will swipe the packet. Why? Because of they have the another P routers, right? Means
So what is my swiping here?
swiping means they will do some modification. They will do modification in their IP addressing, and they just work on this fib table and lfib table, right? We will also talk about like what is the lfib table, how you can maintain it, and what is the fib table, right? Means basically lfib means the local forwarding information base, means the local IP address, right? And fib means uh, forwarding information base table, and we also one more thing that is rfib, right? That is remote forwarding information base, means the neighbor address. So this all the router, all the MPLS router is going to maintain the two things, that's own IP and neighbor IP as well, right? So with using these kind of fib table or L fib table, R fib table, this will maintain these kind of IP addresses till swiping this label, right? So what this will do, this will just provider edge. This provider edge one is sending the message or sending the label towards the provider router, towards the P router. So what the function the P routers will do, that first one that is swipe and second function that is pop, right? So the where is the pop is going to be happen. The pop means where the destination provider edge will exist, right? Where the destination provider edge router will exist, that on that router, that provider router will pop the label, right? In the simple language, if I'm talk about. And the swipe means they do modification according to their requirement, right? Means the MPLS, the internet service providers, because of the see all the provider range, this interface and the all the P routers are working on your on your ISP, internet service provider, right? So the service provider, what this will do, they have multiple kind of facilities, functions, and all the things, right? So some functions can be modified, some functions you have to modify it according to your requirement, because of your requirement is to generate a packet from source to destination, right? So what is your requirement? To generate a packet from source to destination. So that is why this is going to pop the label, and then this will the basic function, sorry, the basic function of the P routers, that is, it is going to check, means this is going to swipe the packet, right? Means simultaneously they just adding their neighbor IP, their own IP in their these tables, and they just informing to the another P routers to send that packet, send that label packet towards the destination, right? So where is my destination? They will just find it out like it. Okay. So the last router, which is this router will also get the label packet which is coming by the P routers, right? Means before like they will also swipe it. This router also will swipe the packet, and then they will just pop it, because of once this will get the packet on this interface, right? Once this router, this P router will get the packet, will get the label on this interface, they will just look their by default behavior, means they will also swipe it, and then they will just pop the packet, because of this router have all the information, like where I have to send the packet, means who is the destination. So this router will look that in the routing table, that I have this interface, and this interface have some IP address, suppose that 10.1 or something like that. So this will look that, okay, means I have to send that packet on this interface, right? So what this will do, this will pop the label, this will pop the labeled packet towards the provider edge, and then the provider edge will forward the packet to the customer edge. So this is gonna be happen between the customer edge, provider edge, and the P routers. I hope you understand. Now, guys, no one will describe you the more than this easiest way, because of this is a too much easiest way that is we have, right? Like we can take one more example if you want, but that's gonna be like the different way, not the routing and all the things, but that's gonna be different way. If you want, so I'll take it. Guys, at least say something.
Yes. Yes. Could you please tell in that way as well?
Okay. Now, suppose that you just planning for a trip, right? Suppose that, and the trip would be 7 days, right? Like Kullu and Manali, right? So whatever the destination that is you have doesn't matter, right? But the way that is you have to spend the time, that is 7 days, right? But how you can just spend it? Suppose that you are going through the Delhi, right? Suppose as this is Delhi, right? Or this is Kanpur or Lucknow, something like that. So whatever it is, okay. So what? How you will go? You will go by the way, right? Means by the road or by the train. Means you have to select. You have to categorize. Like you have the choice. Like you can go via the plane, you can go via the train, or you can go via the by road, right? So you have the multiple way. So what is the way? Like this is the way is your MPLS. The way is your MPLS, right? So inside the way, that is we call swipe and pop. Suppose that you have two ways, that is swipe and pop, right? So what you will do, first of all, if you wanted to go via Delhi, so you have suppose that you have your you just book the ticket by the train, right? So what you have to do, you have to first of all go on the platform, you have to take the train, and then you will just you will just sit inside the train, and then you will just reach on the destination, whatever the destination that is you have, then you will reach on it, right? So swiping means you're just changing the path, means how you have to go, right? Means you are just looking like how I have to reach on the Manali or Kullu, right? Once you reach on the reach on Kullu and Manali, so what you will do, like you have some places, suppose that after popping it you have some place, so what is the place? Like inside the Kullu Manali you have to go on the hills, right? So where, what is the hills? The provider age 2 and the customer age 2. This is your hills, right? Means this is your destination. So this is how you have to go, right? Means till reaching on the Kullu, till reaching on the Kullu, you have to change the multiple trains or the multiple ways, right? So that's all in the simple language if I talk about. I hope you.
Like that, the path.
Yes,
Yeah,
yes.
got it. Mhm.
The path and
Sir,
the process, like how you have to go, right? And the process would be, if I talk about in the technical word, so the process would be swiping
Routing.
and the using protocols and all the things.
Hmm.
सर एक सिंपल टोपोलॉजी अगर डिजाइन करके आप कॉन्फ़िगर करते हैं एमपीएलएस वगैरह एमपीएलएस तो ठीक रहेगा.
So wait, don't worry, we'll just we will on it. Okay, don't worry. Actually, we have these kind of topics to cover. That's why I'm telling you, because of the label filtering, as you can see over here, right? We have that. So that's why I was focusing on it, labeling, like how the labels is going to be generating that. Okay, so that is the main thing, and the provider and the customer edge we also done, right? Now the same thing is also we have to do in IGP protocols as well, right? Means the same process we have to follow, right? So what we'll do over here, that the configuration of the MPLS, right? So that you can understand what is that. Now we have one more thing over here, the types of MPLS also over here, right? Like the multiple kind of MPLS protocol option that is we have, right? Now we have multiple options, like you can just count it as a provider as customer rate with using that, right? So we have the one thing that is the protocol that is LDP, label discovery protocol, right? Label distribution protocol, sorry for that. So like this is the like as we discussed the EIGRP, OSPF and BGP. So let's take the example of BGP. Like inside the BGP, what like how we can make the neighborship with following the 12 path attributes, right? So inside the MPLS, same as in the MPLS, we have LDP, that is we got label distribution protocol, right? So with using this protocol, we form the neighborship between the with using the MPLS protocol. Means if you are going to use MPLS protocol, then you have to configure this LDP protocol on that, right? So how you can do that? So let's talk about it. Okay. So LDP protocol that automatically generates an exchange label between routers, right? As we discussed. Each router will locally generate labels for its prefixes and will then advertise the label values to its neighbors, right? So basically, how this distribution is going to be happen with using the TDP protocol, that is tag distribution protocol, means how you can identify the particular tag or the particular label, so that the TDP protocol is going to help you out, right, to identify your labels and all. Okay, so you have the two things, that is LDP and TDP. Okay, label distribution protocol and tag distribution protocol. So the tag distribution protocol is our Cisco proprietary protocol. Tag distribution protocol is our Cisco based protocol, and LDP is our open standard protocol, right? And by default, you will get the LDP when you are going to configure MPLS. Default protocol mode. Okay. Now, let me just focus the few part of that as well, like how the messages is going to generate in that, right? So let's talk about the the LDP protocol. Like inside the LDP protocol, what are the content that it's going to share, right? So the that version of the LDP protocol, that is same, right? Means the version 1, by default it uses version 1. PDU, protocol data unit, right? So the protocol data unit, whatever the data size that is you have, the data length, that data length will also mention inside this LDP, right? LSR, link state request, right? Link state request ID means where it is coming from, right? So the router ID and all the things will be your links LSR ID, right? And the label space ID. So doesn't matter, right? By default it is 0. So inside the hello message, what are the content that it's going to share it in the hello message? That is uh, that is the TLV, that is we call type length value, right? Means what is the length of that particular value or particular labeled packet. Okay, so the content of hello message, that is the U bit, right? U bit means your unfragment bit, right? Now the message type, like which kind of message it is, message length, message ID. So these kind of parameters is going to share inside the hello message. Okay, now the um, common hello parameters TLB, that is TLB known bits. Just guys forgot it. I think you will not able to understand these things. So let's talk about the configuration part of it, right? Means how you can configure the the MPLS over there, right? So we have the LDP protocol, LDP configuration, means with using, as I told you, that with using the LDP we configure the protocol on it. Okay, so let's talk about that. So we are going to design that one network like that, okay? And then what we are going to do, we are going to configure the OSPF first of all, right? So with using the OSPF, I'm going to advertise that particular interfaces in the MPLS, right? So guys, all of you imported this image file, which is I have told you from yesterday or not? Sorry, for today. Guys, are you there?
Yes, sir.
Yes, sir. Yes, imported.
Okay. So,
Am I on my RDP?
Gaurav, let's just put your IP address and port number in the chat box. I'll work on it. Okay. And whoever
Already.
knows our RDP is not working, so they can just do one thing. They can just put your IP and the port number in the chat box. Just and then we'll work on it. Okay. Just and guys, I'm going to stop this video that is regarding MPLS. Okay. And the configuration which is I'm gonna to do, so that that session I'm going to record it. Okay. So let me stop.